What up, athletes? Whoop, whoop. All right, this is 3.5, triangle proportionality. Your learning target, write it down up top. I will use triangle proportionality by using tables and intercepts. Take a minute. See if you can determine if these are similar. Ready, set, and go. All right, I'm assuming you pause this. I'll assume that throughout. So I'll say pause it at times and just keep going. All right. So just looking at these two, I'm going to check their sides. If I can get side, 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 proportionality, similarity, that would be amazing. Or I could get side, angle, side. That would be amazing. And we'll see from there. All right, looking at these. I don't have any angles, so I'm going to go for side, side, side similarity. So 10 matches 16, so let's see, 10 over 16 simplifies to, let's see, 5 goes in there, or excuse me, 2 goes in there 5 times, 2 goes in there 8 times, perfect. I'm going to match 25 to 40, 25 over 40, 5 goes in there 5 times, 5 goes in there 8 times. And then let's try the last one, 15 to 24, 15, that one looks a little sus. But 3 goes in there 5 times. Look at that. 3 goes in there 8 times. Boom. All equal 5/8. Therefore, yes. That is proportional. It's similar. See these two angles right here. All I have to do is, since all the angles in a triangle add up to 180 degrees, and each is a right triangle, I know these two angles will always add up to 90. So what's 90 minus 35? Well, that's 55 degrees. And what's 90 minus 45? That's 45 degrees. These are different angles, so right away, not similar. No. Quadrilateral is a little different. We see two 90s here, right? And I can even match up these angles, but here's where it gets different. Let's look at the sides. Are you ready for this? So 3 over 9, let's try that. 3 over 9 equals 1/3. Now let's do 5 over 16. Well, that doesn't simplify at all, does it? So this is a no bueno. Awesome. Now again, hopefully you went down and did this. Find the unknown length or angle in each pair of similar polygons. I'm telling you this is similar, so now I got to figure it out. Okay? In this case, I know the angles of a quadrilateral add up to 360 degrees, so I'm going to have 360 minus, since these two angles are going to be congruent to each other, 360 minus 82 plus 115 plus 9. Yeah. And when you throw that in a calculator, that ends up equaling 73 degrees. Boom. Over here, we're going to set up a proportion. And it doesn't matter which direction you go. And I'm going to show you that. So x goes with 8. So I'm going to have x over 8 equals 21 over 12. 21 over 12. I could have just as easily have said 8 over x equals 12 over 21, right? So I could have said that 8 over x equals 12 over 21. The big thing is, if you go big to big, you got to go big to big. If you go small to big, you got to go small to big. But watch, the first move I'm going to do is 12 times x. It's the same no matter how it's set up. So it's going to be 12x equals 8 times 21. And 8 times 21 is 168. Divide both sides by 12. And we get that x equals 14. By the way, probably use less room than me because I'm covering up your vocab section. My bad. Now this one, start on this side so you know, like 20 goes to 36, because there's too much information over here. We don't need it. We need the 20 over 36. And it's going to equal z over 45. Right off the bat, I see that this can simplify. 4 goes in here 5 times, 4 goes in here 9 times. That's a little smaller. So I'm going to end up with 9z equals 5 times 45 is what, 225? And that's a 9, by the way. So divide both sides by 9, and we get that z equals 25. Ooh, right there. Okay, we got some vocab to look at. Let's do that. Mid-segment of a triangle. The segment that connects the midpoints of the legs of a triangle. I believe we actually talked about this the other day, so we'll get more into that. Pause this, write it down. We're going to the next slide. Okay, Theorem 8.8, triangle proportionality theorem. This says if a line is parallel to one side of a triangle, so you see this line parallel to one side of the triangle, and it intersects the other two sides, then it divides the sides into segments of proportional lengths. So in other words, if BE is parallel to CD, then we can say that AB, this distance right here, say that this distance AB divided by, excuse me, got it wrong. I could say that AB, this distance right here, divided by BC is going to equal AE divided by ED. It's a great proportional setup there, okay? Awesome. Write that down, pause this as needed. I'm moving down. Okay, now, right here, Theorem 8.9 is just the opposite. It says, hey, instead, if we're starting from the point that we're saying, hey, AE divided by EB is equal to CD divided by DB, if we're starting there, if we're saying, hey, if that proportionality exists, then it must be that AC is parallel to ED, okay? We're just going the backwards of it. Again, pause this, write it down. I'm moving on to the next thing. Okay, it's important to note that in this example 1, label PC15. I've worked this out a number of times, even live in class, and realized, oh, that doesn't work out the same without it. Sting. So, now we know it does. Okay, if QD is 14.5, where's QD? Right here, 14.5. BP is 9, and PC is 15. Find BQ. And you see right here, we're telling you that QP is parallel to DC. We're saying that with these little lines right here. So then I know there's a proportionality that exists, so I can say 15 over 9 is equal to, we're going to call this X, we don't know what BQ is, 14.5 over X. So then I'm going to cross multiply, 15X equals, and when you multiply that out, it's 130.5. Divide both sides by 15, and we get on a calculator that X equals 8.7. Boom. Done this before, but let's see, 130.5 divided by 15, 8.7 it is. Oh, this one right here, labeled a diagram with given information. I'll click over to that, find the measures that will make MP parallel to RS. So we want to set up the proportionality that will then say, hey, these are parallel. So let's do that. And to do that, we need to go over here. MR is 2.1, so label that on your paper. PN is 10.2. That's the whole thing, not the segment. And PS is 1/5 the length of SN. Well, I'm going to call SN X, and then I'm going to call PS 1/5 X. Okay? All right, let's go back to our page. You can see how I labeled it. So if this is X, this is 1/5 X. There's a couple things I have to do. So let's start off here. If I know that these two add up to 10.2, so I can say X plus 1/5 X equals 10.2. I don't like fractions, get rid of them, just multiply by the denominator. multiply everything by 5, 5 times there, 5 times there, and 5 times here. So 5 times x is 5x. 5 times a fifth cancels out, and I'm left with plus x equals, and 5 times 10.2 is 51. These together make 6x equals 51. Divide both sides by 6. Divided by 6. 8.5. X equals 8.5. There's different ways you can do this, but that means NS right here is 8.5, which is one of our answers, SN, right? Which also means PS is, you can either do 10.2 minus, let's borrow from there, make that 0, 10, borrow from there, make that 9, 12 minus 5 is 7, 9 minus 8 is 1, so it's 1.7. Or I could have said 8.5. If it's right, it should be 8.5 divided by 5, right? Because it's 1/5. So 8.5 divided by 5 should be 1.7. Look at that, it does. So I'm good. So now that I have these two lengths, I can set up proportionality. I can say, all right, so let's kind of cut that off there. I can say 8.5 over 1.7, 8.5 over 1.7. Now I need to find out this big length. Let's give it a different variable. We'll call it y, is equal to y over 2.1. And when I cross multiply, I get 1.7 y equals, and what's 8.5 times 2.1? 17.85 equals 17.85. Divide both sides by 1.7. Look at that, y equals, divide that by 1.7, 10.5. And don't forget that y is that RN, 10.5. Boom, it's a good problem, man. Okay, we got some theorems to burn through. Let's go do it.